Number one can be found in sections, let's say 7.4 through 7.5 in your textbook. Okay, so for problem number one, A, B, and C, 7.4 to 7.5 in your book. So in that problem, we have sine of theta equals 3/5, and theta is in quadrant, it finishes in quadrant 2. So let's go to quadrant 2. And then we know that that's theta there. It opens up like that. And let's just put like a little stick figure person right there. So that's where we position ourselves. And then we have sine, which is opposite over hypotenuse. And Pythagorean theorem gives you -4. You know, the negative because you go to the left. So the picture is ready. Now let's do part A. So part A says cosine of theta. So theta is represented by the person. And then cosine is adjacent over hypotenuse. Done, done, done. Final answer. Part B. So let's see. Part B, we have the tangent of pi over 2 minus theta. Now, pi over 2 is the same as 90. And recall, little timeout, in a right triangle, if one of the angles is theta, then the other one is 90 minus theta. So basically, when they say pi over 2 or 90 over, or 90 minus theta, right? Pi over 2 minus theta, aka 90 minus theta, just means the other location, not where you currently are. So for part B, what we have to do is go for a walk. Instead of here, we are now right there. That's all you do, right? You switch your location. And from this position, give me a tangent. So from this position, tangent is opposite over adjacent. Final answer for part B for number one. Now, one of the facts from earlier in the semester was that the sine of negative theta is equal to negative sine of positive theta. Also remember that cotangent of theta plus n pi equals just regular cotangent of theta if the number n, which is attached to pi, if the number n is even, which for our example it is because it says 200. So by substitution, let's change this into that, and let's change that into that. So let's get this off the board. So by substitution, using the properties, we have negative sine theta plus cotangent of just regular theta. So we have negative. Now sine of theta, that's given, that's 3/5 plus. Now what's cotangent? So theta was represented by the original position of the person, so let them stay there. Now we need cotangent, which is adjacent over opposite. And this is like a calculator, -29 over 15. So final answer for number one, part C. Okay, now number two. So for problem two, we look at section 7.6 in the textbook. So that's where it is for reference. So we want the equation. Now for number two, if you look at the graph, it goes like there's a line, there's a line, and there's a line. And it goes like here, it begins there, and it goes like that, and it goes like this. And we have this one. This is negative pi thirds, and this is 8 pi thirds. And this is 12, and this is -16. And that's 12, and that's -16. So the equation looks like A sine B x minus h plus k. We have to find A, B, H, and K, fill them in, and we're done, done, done. Let's begin by finding the value of K. K is the line that goes down the middle. So to find the middle, you take the top and the bottom and find the average. To find the average, You add the numbers together and divide by 2. That'll give you -2. So -2 is going to be the line in the middle. And that -2 represents the value of k. So we know that k is -2. Hey, we also know that the x-coordinate of the beginning point, that's h. So h was actually given to us for free. It's -π3. What about a? A is the amplitude. So from the middle, how much did you have to go up or down? Let's see. From -2 to 12 positive, that's an increase 14. From -2, -16, you've gone down 14. So your movement was 14. So you know that A is going to be 14, but is it positive or is it negative? Recall, if it looks like this, it's positive, but if it looks like this, it's negative. So ours is a negative sine wave, so that 14 has to be negative. Okay, now the last part is B. To find B, you remember that period equals 2 pi over B. So if you want to find B, first you have to know the period. To find the period, you have to know the end. Let's find the end point. Look for a pattern. From the beginning to the middle, how much did your x-coordinate increase? You went from -1 pi-thirds to +8 pi-thirds. So ignore the pi-thirds because those parts match. Just look at the -1 to +8. If you go from -1 to +8, you've increased by 9. So from 8, increase by 9 more, and that gives you 17. You see that? I added 9. From there to there, I added 9. And from here to here, I added 9. So the end point is at 17 pi-thirds. Let me get this off the board here real fast. Get some space. So we know that the end point here, 17 pi-thirds. But I go back to that equation. Period equals 2 pi over b, where period is the last x minus the original x. So the last x minus the original x, double negative is positive. There's a 1 right there. 17 plus 1 is 18, divided by 3 is 6 with a pi. So 6 pi is our period. We have a period here, so that's 6 pi equals 2 pi over b. You have to solve for b. So what you can do is take both sides of this equation, and you can flip both sides if you want to, like we did in class. Or another option is multiply both sides by b. These will cancel. Then divide by 6 pi. These will cancel. These will cancel. The 2/6 reduces to 1/3. However you want to do it, folks, you get back the fact that b is 1/3. And that goes in right there. So our final answer, let me do it down here in pink. Our final answer should look like y equals -14 sine of 1/3 x plus pi-thirds minus 2. Okay. The plus, because of the subtraction of a negative, a double negative gave us back a positive. So final answer for number 2. All right, number 3, that has to do with inverses. And that idea is in your book in section 8.1 for inverses. So let's see. So for part A, for number 3, we have the sine inverse of the cosine of 7 pi-fourths. Inside out, folks. Do the inside first. Cosine of 7 pi over 4. Unit circle. 7 pi over 4 is there. Cosine is the x-coordinate. The x-coordinate there is square root 2 over 2. So for that reason, the inside disappears, and it gets replaced by square root 2 over 2. But now you want the sine inverse of this. So what you do there is you think of the unit circle. And sine is y. And you want the y-coordinate to equal this. Where on the unit circle is the y-coordinate that number? Well, looking at your unit circle, the y-coordinate is this number here and also there. So which one is it? Do I pick this one or do I pick that one? You have to remember sine inverse. Remember, folks here in blue, that sine inverse goes from there to there, from negative pi over 2 to positive pi over 2. So the only one that fits in these regions would be this location. And that would be at pi over 4. And that is your final answer to 3a. Now 3b, Intelligander, 3b says cosine inverse of tangent of pi. So the inside, unit circle, pi is here, and the coordinates are -1, 0. But the tangent is y over x. So y over x would be 0 over -1, which is 0. So all the inside is just 0. So the inside is 0. So this is cosine inverse of 0. So look at the unit circle. We want cosine, which is the x coordinate, right? Before sine was the y coordinate, but for this one, cosine is the x coordinate. And we want the x coordinate to be 0. Well, that happens there, and that happens here. But cosine inverse, if you remember, cosine inverse goes like that, from 0 to pi. So the only one between these two that fits in this motion would be the one up there, which is located at pi over 2. Final answer. Let's see, number 4. Number 4, that is in section 8.3, the idea of solving equations. So let's see, we have square root 3 plus 2 sine of theta over 7 equals 0. Why don't you subtract that and then divide by 2? So we get the sine of theta 7 equals that. Now, as I look at this equation, this 7's kind of bugging me because I've never really seen theta over 7. Like I've seen theta over 2, I've seen theta, I've seen 2 theta, but theta over 7, it's like, what the heck is that, you know? So why don't we do this? Just for the sake of making it look more familiar, why don't we let theta over 7 equal, let's say, some angle alpha? So let's rewrite this. So this is like sine of alpha equals negative square root 3 over 2. So right away, this looks a little bit nicer. I want you to tell me what alpha is. It's an angle. And it's an angle where sine, or the y-coordinate, is this number. So where, alpha, where is the y-coordinate that? So unit circle. Okay. I think it happens here, and I think it happens there. Because at these locations, the y-coordinate is this number. So alpha has two possibilities, 240 or 300. So these are the possibilities for alpha. So let's run with both of these possibilities. Take 240 for alpha and plug it in there. Then take 300 alpha and plug it in there. So let's see. So we have theta over 7 equals alpha, and alpha has these two possibilities. Let me get some space for us here. So right now, we have theta over 7 equals alpha, but alpha can be 240 or 300. So two setups, like this here, or like this here. Now, solve for theta, because theta is the goal. So let's see, multiply this side by 7. Multiply this side by 7. These cancel. So where's my calculator? 240 times 7. I got 1680, possibly. And here, solve for theta by multiplying by 7. And this theta is 2100. But in the directions, right, if you read the directions on the pink paper, it says that theta is between these two numbers. So that rules out this possibility. And so 1680 is our final answer. Okay, number 5. And number 5, that idea is in section 8.6 in your books. So for this one, we're told that P equals sine plus cosine. And they want us to show that P squared equals 1 plus sine 2 theta. So let's take P and square it. And we show that it gives us this back. So we begin with P squared. So P squared is P times P, right? That's P squared. So if it's P times P, you have to write it twice, right? You square something, you write it twice. Now in red or in pink, let's go FOIL, distributive property. So we get sine times sine, right? Sine times sine. So that's sine squared. Then sine times cosine is sine cosine. Now the inside is again sine times cosine. And in the back, cosine times cosine is cosine squared. In the middle, that's sine, cosine, sine. That's 2 copies. That's 2 copies of sine. So I have 2 sine, cosine. And then I have sine squared, cosine squared. But FYI, remember that sine squared plus cosine squared equals 1. Remember that identity from back in the day? Sine squared plus cosine squared equals 1. And that means that in our problem, sine squared plus cosine squared, that's equal to 1. So we have up here, we have 1 plus 2 sine cosine. So this is 1 plus. Now remember that 2 sine cosine in your double angle identities, 2 sine cosine is just the sine of 2 theta. And that's what we were trying to show. So we're done with this exercise. Number 6, areas of triangles. So for number 6, that idea was in section 9.4. So if you have some graph paper, you can take it out. So we consider the 3 vertices. Now we have a triangle, and what we want is the area of that triangle. So one approach would be to take a rectangle or a square, possibly, who knows, and to enclose the shape. Okay. Now this green rectangle, it goes from 4 to 12, so that's 8. And it goes from 0 to 12, so that's 12. So the dimensions of this green shape are 8 by 12. So the area of that rectangle is 12 times 8, which is 96. So the strategy is going to be this. Let's take this section A, B, C, and D. Find the areas of A, B, C, and D and subtract them from 96. And whatever you get left over is the answer. So what you have to do is find these areas, A, B, C, and D, and subtract them from 96. So for instance, this one here, it's a triangle. So go 1/2 base times height. And if you do that, you get 48. For this one here, this rectangle, you have to find the dimensions. From here to here, that's gonna be 3 because you're going from 4 to 7. And in this part, you're going from 7 to 12, so that's 5. And so 5 times 3 is 15. 15 for this area. And so this is going to be 15. And for this triangle, if you go 1/2 base times height, where this is the base and this is the height, or vice versa, and the same for this one here, you're going to get back 10.5 and 12.5 for those areas. And so the red, right, the triangle in the middle, you find it by accident almost, by going the whole thing, 96, minus 15, minus 12.5, minus 10.5, minus 48, and that should equal 10 square units for the red triangle in the middle. Okay, so now number 7, we want to convert. And number 7, that idea is on section 10.1 in your textbooks. So we want to convert to polar form. 7 square root 2 minus 7 square root 2i. So plot this on the axes. That'll be in quadrant number 4, where this is 7 square root 2, and this is negative 7 square root 2, where this is r, and this is theta, and this little guy is alpha. Now go Pythagorean theorem carefully with these guys, and you'll note that r is 14. Use parentheses on your devices to find r. Should be 14. Now to find theta, first find alpha. And to find alpha, we can go tangent. We know that tangent of alpha, opposite over adjacent, and take the tangent inverse of both sides, and you get, I think it's going to be negative 45 degrees, but we'll take the absolute value. And 45 degrees is going to be just alpha. And that helps you to find theta. So to find theta, it's 45 degrees short of 360. So go 360 minus 45 to get 315 for alpha. So we have R 14 and 315 for alpha, or for theta, excuse me, for theta. Theta is 315. So final answer would look like this. We have R times cosine of theta plus I sine of theta. Or if you want, 14 cosine I sine of 315. Either one. Either of these, 100%. Okay. All right. So number 8. Let's see. Number 8 here. This is on section, I think he said 10.3. So this is, Demois Theorem. So number 8, Demois Theorem. So we have negative 25 square root 3 plus 25i, and all this to the power of 100. Power of 100. So for Demois Theorem, first take that number and convert it to polar form. So that x and y would take you to quadrant 2, like that, and like that. And let's find r with Pythagorean theorem. Do so, and I'll save you time and tell you that r should be 50. Yeah, r should be 50. Now, 90 degrees. Let's find alpha. So we have tangent of alpha equals opposite over adjacent. Now to get rid of tangent, we can use tangent inverse. Tangent inverse, tangent inverse, these are gone. And on a calculator, you should get 30 degrees. If it's negative, just make it positive. 30 degrees for alpha, which means that theta is going to be 150 degrees, because the whole thing's 180. And if you stop 30 degrees short, then you're short at 150. And so we have r and we have theta. So let's rewrite this. We have 100, it's still on the outside, but the inside becomes r times cosine of theta plus I sine of theta. And to apply Demois theorem, remember, you take the power and you give it to the 50. So that's 50 to the 100. But then you take the power and you multiply with 150, which would be 150 with 2 zeros. And then the same thing with the other one, 150 with 2 zeros. And you're done. You leave it like this on the final exam. Leave it 50 to the 100th power, and in cosine of this. However, I'm hoping you're watching this video. You see, this is polar form. But what if on the exam, they want you to do Demois theorem, but they want rectangular form, right? Rectangular is like this. This is polar. With cosine and sine, that's polar. No cosine, sine, that's rectangular. So how do I go from here to the next step, rectangular? Well, you type this into your calculator. You type this into your calculator. And then you go 50 to the 100th. You leave that like that. But you go that times whatever this is. And then plus that times, for example, let me do an example. Let's type that in. Let's actually do this problem here. The cosine of 100, was that 15,000? Like I got back 50 to the 100, and on a calculator, I got negative 1/2. And on this one, sine 15,000, I got back negative square root 3 over 2. Negative square root 3 over 2. So how would I would go this times this and this times that. So I'd go 50 to the 100th times negative 1/2 plus I guess minus because of the negative there. Suppose that would be minus I 50 to the 100 times square root 3 over 2. So this here, that is rectangular because it doesn't have sine cosine. So on the final, if you do Demois Theorem and they want rectangular, then do everything first, polar, Demois, but then here go calculator, calculator, and distribute this to both of the terms separately, and you can just leave it like that. And again, it'll be a multiple choice, so you can see which one looks like this. All right, last question here. The one with the person and the eye height and the building. So the ground, that's the building. And there's a person with a 5-foot eye height. They're 600 feet away. And like this is 17 degrees. So what you should do is you should draw the person's eyesight straight ahead, because this 17 degrees is also 17 degrees there. And I want to focus on this green triangle. So let me draw the green triangle a little bit nicer down here. A little bit nicer. That's still 600, because this 600 is also there, same thing. That's 17. Let's find this number P. And this is 600 feet. So let's go tangent. Tangent of 17 equals opposite over adjacent. Solve for P by multiplying both sides by 600. Cancels 600. Calculator. And I get about 183 for P. And if you take that to the main picture, that would be from there to there, 183 feet. The rest of the height of the building is the height of the observer, their eye height, which was 5 feet, not drawn to scale. So that one's 5, and that's 183. And when you add them together, that's how the answer key got about 188 feet. So draw the person's eyesight, and that gives you another triangle. Draw that one, find its height, and then basically add it with the eye height of the person.